Okay, this is going to get a little bit dicey or confusing. Now it says you need to find all solutions to each equations in radians. And what they mean by that, if you can remember, the trig functions, when you graph them, if you graph it into Desmos, they go on infinitely in both directions, right? So if this is the sine function, it goes on infinitely in positive infinity into negative infinity. And so when it's saying find all solutions, that's what they mean. So if we just had the restricted domain, it would be between 0 and 2 pi. But if it has to continue to go on for sine, cosine, cosecant, and secant, its full period is between 0 and 2 pi. So if you add 2 pi continuously, so if we do it once, well, then you'd have to do it again. You'd have to have 4 pi, then 6 pi, then 8 pi. So if you add a little, either a k or an n, so that would be once or twice, or it doesn't matter. That n right there, that little, the n or the k represents how many times, and that could be infinity. So you're going to get your basic solution. So let's say it was the original. So we had to solve an equation, and we ended up getting the theta. The theta is equal to pi thirds, and let me think about. I'm going to keep it easy myself. 0 and pi. Well, that's between 0 and 2 pi. Those are the solutions. But if I have to go on infinitely, then I would say 0 plus or minus 2 pi k or 2 pi n, and I would say pi plus or minus 2 pi k. And that would be for these four. But remember, for cotangent and tangent, one of their full cycles happens between 0 and pi. So when it's a tangent or cotangent, we're going to add pi n to both. So let's go through a couple examples and I'll tell you what I mean. So I'm going to do something like this. All right, so we need to get the theta by itself. And so the first thing I'm going to do is I'm going to divide both sides by 6. And then negative 3 over 6 simplifies to negative root 3 over 2. And I think that I started doing this down here. There we go. And then if you look at and then we're going to take an arc sine of both sides. And this is where you can look at the unit circle. So when you look at the unit circle, sine is negative down here and down here, and that's a 60-degree angle. So right down here, so if this is pi thirds, sine is 3 pi halves. So 1 pi thirds, 2 pi thirds, 3 pi thirds. So we're talking about 4 pi thirds and 5 pi thirds. All right. So all I said was we're going to take the arc sine of both sides. And when we do that, that goes away, leaving theta over 3. And we have 4 pi thirds plus, remember, we're finding all solutions. So we have to add, since this is sine, we have to add 2 pi n. So 5 pi thirds plus 2 pi n. But that's for 1/3 the theta. Now we're going, so we need to multiply everything by 3. And when we do that, theta is going to equal, well, that will cancel with that, leaving 4 pi. 3 times 2 pi n is 6 pi n. When we multiply that by 3, that becomes 5 pi plus 3 times 2 pi n is 6 pi n. And I think, let's see if there's another one over here that we need to do. Here, we'll do this one right here. So we need to get this theta by itself. The equal sign is right there. First thing that I'm going to do is I'm going to add 3 to both sides. That cancels with that. When I add it over here, when I add 3 over here, notice there's a 3 in the denominator. So 9 divided by 3 is 3. So I just added 9/3 to this. Well, negative 8/3 plus 9/3, this just ends up being 1/3. Well, on the left side, we have negative 1 over 3 attached by multiplication. So I'm just going to multiply both sides by negative 3. When that happens, we get tangent theta halves plus 5 pi 6 is equal to, well, 1/3 times negative 3 is negative 1. And then, remember, we need to get rid of this tan. We're going to take the arc tangent of both sides. That cancels, leaving theta divided by 2 plus 5 pi 6. Remember, tangent is 1 or negative 1 at the 45-degree angles. And tangent is negative in these two quadrants. So if this is pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths, 6 pi fourths, 7 pi fourths. So I can go ahead and put that right now. The two that are negative are 3 pi fourths and 7 pi fourths. I'm going to make some more room here. All right. But notice we're not finished. We have to get this theta by itself. So the first thing we're going to have to do, let me make this a little bit bigger. We have to subtract this 5 pi 6. And when we do that, we have to subtract it from both of those. That goes away, and that leaves theta over 2. Oh, well, these don't have the same denominator, so let's see. 12 is the first number they have in common. If I multiply this top and bottom by 3, I get 9 pi 12, subtract. If I multiply top and bottom by 2, because 2 times 6 is 12, I get 10 pi 12ths. And then we have to do the same. I'm going to multiply top and bottom by 3, top and bottom by 2. That gives me 21 pi 12ths. Subtract 10 pi 12ths. So theta divided by 2 is equal to negative 9 subtract 10 is negative 1. I could put negative 1 or just negative pi 12ths. And 21 subtract 10 is 11 pi 12ths. But remember, we're wanting to find all solutions, and this is tangent. So I have to add pi n. Add pi n to both sides. And then I'm going to multiply everything by 2. And then, so some professors are going to allow you to leave that. So this right here becomes negative pi 6 plus pi n. And when we multiply everything here by 2, that becomes 11 pi 6 plus 2 pi n plus 2 pi n. Here's the dilemma. This theta over 2, remember, we're talking about its half as wavy. So we're only going to be talking about half of the thetas. So this one is not going to fit. So we'll be talking about this one right here, 11 pi 6 plus 2 pi n, and the n means just infinitely. Infinitely we're going to, we can find all the rest of the angles. All right, it's a little bit complicated. We'll have to work on this one in class, and I'll have to clear some things up, but you'll get good at it.